The next distribution plot to look at is the box plot. It's a graphical representation of the distribution of data set along a single axis. It summarizes the distribution of a continuous variable by displaying key statistical measures such as median, quartiles, and the outliers. It consists of a rectangular box or the box with a line inside it which represents the median, and these lines extending from the box, there are lines which are extending from the box which are called whiskers. The box represents a interquartile range IQR which consists of middle 50% of the data. That means the box begins at end of first quartile, that is 25%, and goes up to end of third quartile, that is 75%. That means the 25% to 75%, that is 50% of the data is shown as an interquartile range, and that is what a box represents. The whiskers extend from the box to minimum and maximum values within a certain range. Like first we understand the length of the box, that is IQR. Then we consider 1.5 times this IQR and extend it above maximum and below minimum, and we mark them as minimum and maximum, and anything below minimum point is assumed to be an outsider. Anything above the maximum point is assumed to be outsider, and so on. So that's about outliers. So the key features are the box, median line, whiskers, and outliers. So here we represent this. So the data is first spread out in the ascending order. Then the midpoint is identified, and that midpoint is called the median. So all the data, whatever we have, we just arrange them in an ascending order and select the middle one, that is the median. Same way we select the 25% position and 75% position. The 25 percentile we call it quarter 1, the 75 percentile we call it quarter 3. So the length from quarter 1 to quarter 3 is the interquartile range, and that is represented with a box, and the median position is shown by a line. Then from the minimum value, that is from the quarter 1, we go down by 1.5 times IQR, and that's where we call it a minimum. So a line is drawn on the other side of the minimum of length of 1.5 times IQR, and there we represent that as a minimum. Any values below that minimum will be outliers. Same way from the Q3 we extend the line by 1.5 times of IQR and call that point as maximum. Any data which is beyond that maximum are assumed to be outliers. So that's how the box plot is represented. And if we want to represent multiple data box plot, multiple feature box plot, then we are showing in the different box plots. The dots in each color represent one feature, and so these features are arranged in ascending order, and then middle of that is selected, the point which is at the middle is selected, and that becomes the median. And then 25% is marked, 75% is marked, so between these two is a box, and at 50% we have a line. Then below first quarter 1.5 times IQR, above third quarter 1.5 times IQR will represent minimum, maximum respectively, and anything beyond this minimum, maximum are called outliers. So same way for different colors, different data are represented. So it's talking about fall location versus age. So here, if we are on fallen in the ale, then what is the pattern? So it says that the median happens to be somewhere 40 years. First quartile is around 30, and third quartile is around 65. So from 30 to 65 we have a box, and that length is IQR 1.5 times that we compute, and we plot two whiskers, that is minimum and maximum. If any data are there beyond these two, we call them outliers. So same way for ale, for bathroom, for recreation and hospital. Now if you look at the data, we find that a number of data points are more in the bathroom, because usually the bathroom is having water on the tiles, which makes it slippery, so the chances of falling will increase if it is a bathroom. Same case, it all depends again on the age, and depending on the age, depending on the type of the room, we have plotted these densities as a box plot. So that's box plot is giving so much of information in one slide or one plot. So that's a advantage of working with the box plot.